So this is um, Unit 2, Lesson 6 of our calculus class. Unit 2 is called derivatives. Lesson 6 is called power functions. Round 2. What we're going to learn is how to use power rule with more complicated functions, and then how to use power rule with double derivatives, and more. So first of all, double derivative is a derivative of a derivative. So if we say that the derivative of f prime of x would be a double derivative of f. So we just take the derivative, f prime, and take the derivative of that again. So we can notate this by f double prime of x. So we got this f and two apostrophes. We can say this is the double derivative of f with respect to x, or we could just say f double prime of x. This is our British notation. Our German notation would look like this. So if the derivative of y is dy with respect to x, then d squared y with respect to dx squared would be our double derivative notation there. And you could continue this process to find third derivative or fourth derivative. You just, add more apostrophes or higher exponents. So examples, we could apply the power rule to find the derivative of this function right here. First, we're going to write this function as a power format. So we're going to take that x and make it out in front of a coefficient of 3 over 2. And the exponent on that x would be negative 1. And so when we use power rule, we multiply the 3 over 2 by negative 1, and we subtract 1 from the exponent. We end up with negative 3 over 2 times x to the power of negative 2, or negative 3 over 2x squared. Same here. We have a radical function that we can write as an exponential or a power function. So square root is nothing but a power of 1 over 2. So negative 6 times the square root of x to the power of 3 is equal to negative 6 times x to the power of 3 to the power of 1/2, which, if we know exponent rules, we can multiply those powers. Power of 3 to the power of 1/2 is the same thing as x to the power of 3/2. So now it's clear we can use power rule. We multiply the negative 6 by 3/2, and then we subtract 1 from the exponent. We're left with an exponent of 1/2. And negative 6 times 3 over 2 would be negative 9. So we have negative 9x to the power of 1/2 would be f prime. And we can write that as negative 9 times the square root of x. If this was a quiz question and you derived f prime and wrote a function as a power, and you didn't write it as a radical, that's totally fine. I don't really care. In general, you just want to read the directions on a question to see if they have a particular format that they prefer. If the question says, write the derivative as a radical function, you definitely want to write negative 9 square root of x. But if they were to say, write it as a rational exponent, then we'd write like this. Okay, here's another one. So if y is equal to 1 over 2 times the 6th root of x to the power of 5, we can write this as a rational exponent. Because our x variable is in the denominator, it's going to be a negative exponent out front. And we can take a 6th root to the power of 5 and write that as a rational exponent 5 over 6. And you can usually see those numbers translate from radical form to exponential form nicely as a fraction. So when we do power rule, we're going to multiply the 1/2 by the negative 5 over 6. And then we're going to subtract 1 from the 5 over 6. We're going to get negative 5 over 12 x to the power of negative 11 over 6. And we can, again, leave that in this form, or we can write it as a quotient with a radical on the bottom. We do have, if you write it as a radical, we do have x to the power of 11 inside of a 6th root. So we could take 6 of those x's out, and it would be negative 5 over 12x times the 6th root of x to the power of 5. So if we did have to simplify this fully, we'd want to pull some x's out of there. All right, so if I have a function f, what's f double prime of x? Well, to find double prime and then triple prime, we first have to find f prime. So we're going to do power rule over each term separately. We end up with f prime equals 5 over 2x to the power of negative 4 plus 1 half x to the power of negative 2 plus 6x to the power of 2. And now, because we're going to find the double and triple derivatives, we're just going to leave these in power form. We're just going to leave them with x to the power of something because we want to do power rule again. So to find double prime, I'm going to do the exact same process with power rule. We're just going to start with f prime instead of starting with f. So multiply the 5 over 2 by the negative 4, and then subtract 1 from the exponent. So since we have a negative exponent, it's going to be a larger absolute value. So negative 4 goes to negative 5. When we multiply the 1 half times the negative 2, we get negative 1. And then subtract 1 from our exponent, we get to negative 3. And then power rule here as well, we get 12x. So here's f double prime of x. We just do power rule twice. F triple prime, we just do power rule again. So for f triple prime of x, we start with f double prime, and we do power rule for each term. All right, so here's the same kind of problem, but written with our Leibniz notation, so the German guy. So we want to find, given y, find d squared y with respect to dx squared, and d cubed y with respect to dx cubed. So first we're going to find dy dx. We do power rule, and we got some fractions here, but we ain't scared of no fractions. So we use power rule here, we get dy dx equals negative 1 over 16 minus 8 over 3 x to the power of 3 minus 1 over 6 x to the power of negative 5. And so to find the double derivative, we'll just take the derivative of dy dx. And that's going to give us, we have a constant term, so we use power rule here, that just washes to 0. So we have two terms left we use power rule on. And so our double derivative is negative 8x squared plus 5/6 x to the negative 6th power. To find the triple derivative, or d cubed y over with respect to dx cubed, we're just going to take the derivative of the double derivative. So power rule, and we get our triple derivative is the negative 16x minus 5x to the power of negative 7. All right, so hopefully now we have a little more confidence working with power rules on power functions. The one of the biggest things here is working with x in the denominator and working with radical functions. So do you know how and when to use a exponent that's negative and when to use an exponent that's rational? If you're good with those kind of conversions, then this isn't too big of a leap. If you're not very familiar with those, well, you want to brush up on those because they aren't going away anytime soon.